Okay. So once again, good afternoon to everyone. So up to it. Okay. So up to it, we can study the various types of image enhancement techniques. Okay. So in last lecture, we can study the histogram and the different types of histograms. Okay. So basically, we can study the three main types. That is a histogram modeling, histogram equalization, and histogram specifications. Okay. So have you any doubts in these three types? Okay. So the histogram modeling and histogram equalization is simple. Okay. But to understand the histogram specifications, we have to only match the two histograms. Okay. So we'll also take the examples on these three types. Okay. So you have to only focus on an example of histogram specifications. Okay. So it is little bit difficult to understand. Okay. So is there any problem in these three types? Have you understood it? Okay. So based on this histogram, might be there is a examples, your question paper. So you have to study the three types of histogram and also the various types of examples on a histogram. So example might be uh, most of the time on the histogram equalization. So they can provide a one simple image and the question is equalize the given histogram. Okay. So with the help of various mathematical calculations and various steps, we have to equalize the histogram. Okay. So now we have to start the next point, that is various types of filters. Okay. So okay, so we have to study the what is a filter, what are the different types of filter, and why the such type of filters can be used in a image enhancement. Okay. So can anyone tell me what is the basic function of filter? For what purpose we can use a filter? Okay,
To reduce noise.
my voice is clear to everyone. Okay. Okay. So the basically the filters can be used to remove the unwanted things in a circuit. Okay. So as we deal with various types of images, so it is an unwanted thing. So it might be a noise. So why we can call as a noise? So due to this noise, we get some disturbance. Okay. So we can call as an unwanted disturbance, or we can call as a noise. Okay. So there are various types of noises that can be studied, that can be included in our fifth chapter. Okay. So the basic idea to study the filter is that we have to simply reduce the noises from the image. Okay. Then what is a noise? What are the different types of noises? How we can represent the noise? Okay. So that concept we have to study in detail in our chapter number 5. Okay. So here why we can use a filter. So as we study, our unit is image enhancement. Okay. So basically the image enhancement can be used to improve the quality of input image. Okay. So in order to improve the quality of input image, so for example, if the input image is too dark, okay, so due to the darkness we are not able to visualize the content properly, right? So if we have to identify the image properly, so we can apply the various point processings. So it may be a contrast stretching, right? So it may be a intensity level slicing, it may be a beat plane slicing. Okay, so using various techniques, we can simply improve the quality of input image. But when we improve the quality, so at that time Okay, so due to the various errors, the noise can be added in that image. So due to the added noise, also we are not able to visualize the image properly. Okay, so as we increase the brightness, so along with increasing brightness, so there is also disturbance can be increased, or disturbance can be added in the output image. Okay, so what is our aim? So we have to simply improve the quality of output image. Okay, so in that case we have to remove the noise. Okay, so in order to remove the noise, we have to use the various types of filters. Okay, so for that purpose we can study the various types of techniques. It may be a point processing or it may be a histograms. Okay, so there is a one more technique which can uh, provide, yeah, which can uh, provide the both functions. So it can also enhance the quality of input image, as well as it can remove the noise from the image. Okay, so up to it we can study only the image enhancement techniques which can improve only the quality of input image. Okay, have you understood it? Okay. So up to various point processing techniques or histogram techniques, we are not removing any type of noise. Okay, so in that case, we are not using various types of filters. Okay, so that techniques simply improve the quality of input image. Okay, but again, with improving quality of image, it can also improve the noise level also. Okay, so in order to perform the both functions, we have to use the one more image enhancement technique, that is a homomorphic filtering. Okay, so it is a homomorphic filtering, how it can enhance the quality of input image, as well as how it can remove the noise from the images. So that we have to study in the homomorphic filtering. Okay, so again, the homomorphic filtering is the most important point in our unit number 3. Okay, so most of the time there is a question on a homomorphic filtering. So it having a small mathematical derivation. What is the concept of homomorphic filtering, and how we can reduce the noise, as well as how we can enhance the quality of input image by using a homomorphic filtering. Okay, so as we mentioned, the homomorphic filtering can be used for multiple functions. Okay, okay, my voice is clear. It is audible to everyone. Roll number 22. Yes, 22 is there.
Yes, sir.
Okay, okay, mute yourself. Okay, so as we discuss, the homomorphic filtering can be used for various, yeah, it can be used for multiple purposes. It can provide multiple functions. So the basic two main functions are, so it can improve the quality of input image, as well as it can remove the various types of noises of the image. Okay, so as we convert the analog image into the digital image, okay, so in that case also the various types of noises can be added in the image. Okay, so the basic aim of filtering is that it can reduce the various types of noises. Now again we have to study the different types of filters. Okay, so basically we have to study the three types of filters. It is a low pass filter, high pass filter, and band pass filter. Okay, so again might be you can study in your digital signal processing also, you can study the various types of filters, right? So for our image enhancement we have to study the three main types of filter. Okay, so that part also we can discuss in the same lecture. Okay. Okay. Now, how we can use the homomorphic filtering can be uh, for the noise reduction as well as for the improving quality of input image. Now, to study the homomorphic filtering, we have to study, yeah, we have to first understand how the image can be created. Okay, so as we discussed in our first lecture, so how the image can be created. So for that, we can study the image formation model. Okay, so in our earlier lectures, we can study how the image can be captured in our human eye. So can anyone remember it? How the image can be formed? So yeah, what is the basic condition for image formation? Yes, can anyone? Samir Patan, what is the time for lecture? Okay, now tell me how the image can be created in our human eye. Yes, can anyone? Okay, so as we discussed in our earlier lectures, in order to form the image, we require some incident light. Okay, so we require the light from sunlight. Yeah, also it might be a light from our photo digital cameras. Okay, so such we can use our mobile cameras also. So in that we can focus some incident light on a particular object. Okay, so if we consider there is a total dark area, yeah, if we have a total dark room, right? So in that dark room there is no incident light. Okay, so to form the image, we require some incident light. So we can provide the incident light. Yeah, we can use the light from our mobile cameras or digital cameras, or it may be from the uh, sunlight. Okay, so if we take an example of sunlight, okay, so if I have to visualize any object, so the first the sunlight can be focused on that particular object. Okay, so now we can also observe our mobile phones. Okay, so how the image of mobile phone can be created in our human eye. So first the sunlight can be focused on our mobile phone, and that mobile phone can reflect that sunlight, and that reflected sunlight can be captured by our human eye. Okay, so due to this we can visualize the images. Okay, so these two concepts we have to use for homomorphic filtering. Okay, so one is called as a illumination and another is called as a reflection. Now, what is the illumination and what is the reflection? So, for homomorphic filtering, we have to use these two concepts. So, illumination means what are the input, yeah, what are the incident light, and the reflection means what are the reflected light from that object. So we have to consider the illumination source and the reflectance source, so the incident light as well as a reflected light. Okay, so have you understood what is the illumination and reflection? Okay, so it is the illumination. So the illumination simply nothing but the incident light. The reflectance means it is a reflected light from that particular object. Okay. Okay. For the homomorphic filtering, uh, yeah, in order to design a homomorphic filtering, we have a certain steps, right? It is similar. Yeah, also, we can study the block diagram of power supply in your electronic subject. So, in order to convert the AC supply into DC supply, we require various types of steps. So, it may be a step down transformer, rectifiers, filters, voltage regulators, right? So have you memorized that block diagram of power supply? Yes. Okay. So similar to that, again, in order to achieve, yeah, in order to implement the homomorphic filtering, we require the certain steps. So by using these steps, we can use, yeah, we can enhance the quality of input image and we can reduce the certain type of noise. Okay. So first thing, what is the input source? The always the input might be an incident light. So that can be called as a illumination intensity or illumination light. Okay. So here we can consider the illumination source is L of xy. So why we can consider xy? Because we can represent the image into the two coordinates, as in x coordinate and in y coordinate. Okay. So first, what are the illumination source? That we have to take the logarithmic function of that. So why we can take the logarithmic function? Yeah, what is the main basic function of logarithmic function? Okay, so that point also we can study in a logarithmic transformation, right? So in order to compact the wider range into the smaller range, we can use the logarithmic functions. So here we can take, we can apply the logarithmic function on an input image. So after applying logarithmic function, we can take the Fourier transform. So why can take the Fourier transform? Because we have to convert the domain. So it might be we have to convert the uh, information from the spatial domain into the, yeah, we have to convert the input image, yeah, we have to convert the various spatial values into the digital values, right? So simply we have to change the domain of image. So for that purpose we have to use the discrete Fourier transform. Okay, so again, in second unit, we can study the concept of discrete Fourier transform and the various types of Fourier transform. So by using this transform, we can convert the uh, illumination source, that is a L of xy, into the another domain, so that is represented by H of uv. Okay, so again, if we have to bring back the image into the original format, so again we can uh, take the reverse action. So instead of DFT, we can apply the inverse discrete Fourier transform, and instead of logarithmic function, we can take the exponential function. Okay, so by using these steps, we can improve, yeah, we can get the output image. Okay, so the output image consists of, it is the enhancement in an input image, as well as it can reduce the various noises present from the image. Okay, so if you observe the two figures, okay, so here we can take a one original picture. Okay, and on that picture we can apply the homomorphic filtering. So can you observe the difference between two images? Yes,
Yes, sir.
right? So as we apply the homomorphic filtering, so it can improve the quality of input image. Also, it can reduce the various types of noises. So as we observe the image, so we can observe there is a some change in intensity level. So as compared to the left hand side image and right hand side image, we can observe the right hand side image more properly. Okay, so by using the homomorphic filtering, we can improve the quality of input image. Okay, so by observing these two pictures, we can get the idea regarding how the homomorphic filtering can be useful to enhance the quality of input image. Okay, but what is the basic difference between the another type of image enhancement techniques and homomorphic filtering? So the difference is that along with image enhancement, it can also remove the various types of noises. Okay, so this is the basic use of homomorphic filtering. So there is a little mathematical equation for homomorphic filtering. So as we so everyone observe the block diagram. Okay, so in block diagram we can mention various steps. So at the left side we can take a one input. So first we can apply the logarithmic function. After logarithmic function we can take the Fourier transform. So after Fourier transform the domain can be changed and the xy can be converted into the uv. Again we can apply inverse discrete Fourier transform and we take the exponential function. So again we can got the image in the format of x and y coordinates. Okay, so this block diagram can be mentioned with the help of mathematical steps. Okay, so everyone, have you observed these mathematical equations? Okay, so first function is we have to take a one input image. For input image can be represented by f of xy, right? So we have to consider the two types of sources, that is the illumination source and the reflectance source. So the illumination source can be represented by uh, I of xy and the reflectance source can be represented with r of xy. Okay, so everyone try to focus on a first mathematical equation. So how we can represent the image with the help of illumination and reflectance. Okay, so the image can be formed with the help of these two functions. Okay, so we have to take a two functions and we have to represent the image. So in order to form the image we require the illumination source as well as a reflectance source. Okay, so here we can mention the image as f of xy is equal to I of xy into r of xy. So everyone, the first point is clear. The first step is clear. How we can mention the image with the help of illumination as well as reflectance source. Okay, so it is a simple mathematical equation. Okay, so is there any doubt how we can represent the image? ठीक है, समझना का इक्वेशन? Yes. Yes. Have you understood it? Okay. So with the help of illumination, so everyone try to listen carefully. So with the help of illumination and reflectance source, we can mention the image and that can be represented as a f of xy. So after that, we can take the logarithmic functions. So it can be mentioned as a ln. Okay, so if we take the logarithm functions, the multiplication part can be converted into the addition. So here we can represent ln I of xy plus ln r of xy, right? So after that, we can apply the discrete Fourier transform. So after applying the discrete Fourier transform, the xy coordinate can be converted into the uv coordinate. Okay, so at the last step we can convert the xy domain into the uv information. Okay, so here the image can be represented in a uv coordinates instead of xy coordinates. Okay, after that again we can apply the inverse Fourier transform. Okay, so here we can mention the f inverse. Again, if we take the inverse Fourier transform, the UV information can be bring back into the XY information. Okay, so after the inverse Fourier transform, we have to apply the exponential function. Okay, so in this way, we can derive the equation for homomorphic filtering. So as we observe the block diagram, so how to derive the these mathematical equations. So if you rememberize this block diagram, so it is easy to derive this mathematical equation. Okay, so what I have to do? So first we have to consider the input image. So the input image nothing but it is the combination of illumination source as well as reflectance source. So on that image we have to apply the logarithmic function. After applying logarithmic function, in order to change the domain, we have to use the discrete Fourier transform. So by using discrete Fourier transform, we can change xy into uv. Okay. So again, to bring back the image in original format, we have to apply the inverse Fourier transform, and after inverse Fourier transform, we have to apply the exponential function. Okay, so the f of xy can be converted into the g of xy. Okay, so our g of xy nothing but the output of homomorphic filtering. So it can enhance the quality of input image as well as it can remove the various types of noises on the image. Okay, so this mathematical equation is too important according to your exam point of view. Okay, so simply we have to go with a block diagram. Okay, so after homomorphic filtering, we have to study the various types of filtering. Okay, so basically we have to study the three types of filter: low pass filter, high pass filter, and band pass filter. Okay, so what is a function of low pass filter, what is a function of high pass filter, and what is a function of band pass filter. So that basic idea we also studied in our DSP also. Okay, so can anyone tell what is the function of low pass filter? Yes, can anyone tell what is the function of low pass filter? Roll number 38. 30 is there.
Yes, sir.
Okay, so these are the simple types of filter that also we can study in our electronic subject. Okay, so basically what we have to study in our image processing is that, so we have to study the functions of these three types of filter: low pass filter, high pass filter, and band pass filter. Okay, so along with these three types of filter, we have to study the two more functions. One is called as a blurring and another is called as a sharpening. Okay, so what is meant by blur? Yeah, what is meant by sharpening? So that point also we can cover after the three types of filter. Okay, so basically what we have to study in these three types of filter is that we have to study the mathematical equations of these three types of filter and how it can be represented in the two coordinates. Okay, so as we study, yeah, as we deal with various types of images, so the image can always represent with the two coordinates. One is a x and another is a y. Okay, so similarly, we have to represent these three types of filter in a two coordinates. So for that, we have to study the simple diagrams and the various mathematical equations of the various types of filters. Okay, so again, we have to study the various types of subtypes. That is a if we consider the low pass filter, so it having ideal low pass filter, Butterworth low pass filter, and Gaussian low pass filter. So everyone keep this 3 point in mind. Okay, so first one is a ideal. So if we consider the low pass filter, so we have to study the low pass filter as well as the three sub points. So first one is a ideal low pass filter, Butterworth low pass filter, and Gaussian low pass filter. Okay. If we study the high pass filter, then again we have to study the three types: ideal high pass filter, Butterworth high pass filter, and Gaussian high pass filter. Okay. So simply we have to study the mathematical equation and the representation of these three type of noises. Okay. So clear. Okay, so might be it is little bit difficult to understand because it consists of only the so as we study, so it having only the mathematical equations and how the uh, output of that particular filter will be look like. Okay, so that part we'll discuss in our next lecture. Okay, so the important thing is that simply we have to study the various types of filters, right? So as we changes our spatial domain information into the frequency domain information, as we change the domain, so we have to use various types of transform. So we can use a Fourier transform. So by using the Fourier transform, we can change the domain. That is, information from the spatial domain can be converted into the frequency domain. Okay. But if we use the various types of transforms, then how the image will be look like? Yeah, how the three type can be represented by using the mathematical equations as well as by the various diagrams. Okay, so simply I'll show you what we have to study in the low pass filter. Okay, so if we take the uh, yeah, if we consider the low pass filter, we have to study the basic function of low pass filter and the three subtypes. That one is a ideal low pass filter, Butterworth low pass filter, and Gaussian low pass filter. Okay, so simply, so everyone focus on a slide. So here we can represent the ideal low pass filter. The ideal low pass filter can be represented with a mathematical equation and in a particular coordinate. Okay, so here we can consider UV coordinate. So can anyone tell why we can consider UV coordinate instead of XY coordinate? Okay, so as we change the spatial information into the frequency domain, we can use various transforms. Okay, so by using this transform, we can change the spatial information into the frequency domain. So as these are the three types which are related to the frequency domains. Okay, so that's why instead of XY plane, we can consider the UV plane. Okay, so likewise this, so diagram and mathematical equation, we have to study the three types of filter. Okay, so any doubts? Okay, so these three types of filter we can discuss in our next lecture. Okay. So simply I'll give the brief idea and the simple idea what we have to study in these three types of filter. So we have to study the three types of filter and its subtype. So if we have to study the low pass filter, we have to study ideal low pass filter, Butterworth low pass filter, and Gaussian low pass filter. Okay, so in that we have to study only the mathematical equations and its representation. Okay, so it is clear.
Yes, sir.
Okay, so that part will continue our next lecture. So okay, so today we'll stop here. Now we can put your attendance, but in a sequence. Start with roll number 1, and put attendance in a proper sequence. Chapter 6.
हॅलो.
Yes.
सर ते
Is any problem?
हा सर एट प्रेझेंट आहे ते फेल टू सेंड म्हणाले.
Okay. So after 8, you can put your numbers. 8, 9. ऋषिकेश फोड दे. 10 नंतर 39 आहे का? Why you put your number in between? Yes, after 10, 11, 12, 13, 14, 15. Okay, 15 to 20. 21 to 25. 25 to 30. 31 to 35. 36 to 40. सुशांत हलदार एकदा नंबर पुट केल्यानंतर चालतंय की. 41 to 45. ठीक आहे, ज्याने नंबर पुट केले ते लेफ्ट होऊ शकतात. 45 to 50. 51 to 57.